This is Bob Capetta from the College of the Florida Keys, and this is another video on the Intermediate Algebra Final Exam Review, starting with problem 24. So we have to solve a system of equations. X minus 4y is 9, and 2x plus 3y is 1. I think I'll solve this with substitution. So my first equation is x minus 4y equals 9. Let's solve for x. Let's add 4y to both sides. So I get x is 9 plus 4y, and I'm going to substitute that in for x over here. So 2 times x will become 2 times 9 plus 4y, plus 3y is 1. 2 times 9 is 18. 2 times 4y is 8y, plus 3y is 1. So I get 18 plus 8y and 3y is 11y equals 1. Subtract 18 from both sides, and I get 11y is negative 17. Divide by 11, and I get y is negative 17/11. Now, I'm not that thrilled about plugging negative 17/11 in there to solve for x. So what I think I'm going to do instead is I'm going to eliminate variables to solve for x. I'm going to eliminate the y's. So this is kind of half substitution, half elimination. So let's try that. Let's go x minus 4y equals 9, 2x plus 3y is 1. I want to solve for x, which means I've got to eliminate the y's. So I'll multiply the first equation by 3 and the second one by 4. So I get 3x minus 12y is 27. I get 8x plus 12y is 4. Add those together, what do we get? Negative 12y and 12y is 0. 8x and 3x is 11x. 27 and 4 is 31. Divide by 11. So we think x is 31/11. I think it's a good idea to check. So x 31/11 minus 4 times negative 17/11 using my calculator. I get 9. That checks. 2 times 31/11 plus 3 times negative 17/11 using my calculator. I get 1. So I'm confident that is correct. So I'm going to write it in curly brace form. X is 31/11 and y is negative 17/11. So solve that one by substitution. That was number 24. Okay, our next problem is number 25. 1/25 over 64 to the negative 2/3 power. So let's quickly do that one. 125 over 64 to the negative 2/3. So what do I get? I get 125 to the negative 2/3 over 64 to the negative 2/3. So again, we're going to play the top and bottom game. So the top is 125 to the negative 2/3, which is the same as 1 over 125 to the 2/3, which is 1 over the cube root of 125 squared. Well, 125 is 5 times 5 times 5. 1 over the cube root of 5 times 5 times 5 squared, which is 1 over 5 squared, which is 1/25. So that's the top. How about the bottom? The bottom is 64 to the negative 2/3, which is 1 over 64 to the 2/3, which is 1 over cube root of 64 squared. 64 is 4 times 4 times 4, or 22. Cube root of 4 times 4 times 4 squared, which is 1 over 4 squared, which is 1/16. So the top is over here is 1/25. The bottom is here, which is 1/16. We'll finish this by taking top divided by bottom. top 1/25th divided by the bottom divided by 1/16th, which invert and multiply 1/25th times 16 over 1, which is 16/25ths, is that one. All right, next we want to rewrite in simplest radical form. Number that was 25, so our next one is number 26. Simplest radical form. We have the 10th root of x to the 8th, and we are assuming that x is positive. The 10th root of x to the 8 is x to the 8 tenths, which is the same when we reduce the fraction as x to the 4 fifths, which is the 5th root of x to the 4th. So this is simplest form with an exponent. This is simplest form with a radical. And the question I asked for was simplest radical form, so that would be the 5th root of x to the 4th. 27 asks us to multiply two irrational numbers, 5 plus 3 root 2 squared, which means 5 plus 3 root 2 times 5 plus 3 root 2. Let me use my multiplication box to make sense of this. Five plus 3 root 2, 5 plus 3 root 2. 5 times 5 is 25, 5 times 3 root 2 is 15 root 2, 5 times 3 root 2 is 15 root 2. 3 times 3 is 9, root 2 times root 2 is root 4, which of course is 2, and that gives me 18. So, adding those together, we get 25 plus 18, which is 43, plus 15 root 2 and another 15 root 2 is 30 root 2. And that's my answer to number 27. 28 asks me to rationalize a denominator. 28, I have 3 over the cube root of 5. Take a look at that. 3 over the cube root of 5. To rationalize the denominator, how many 5s do I need to undo a cube root? I need 3, so I have 1. I need 2 more. So multiply by the cube root of 5 times 5 on the bottom, multiply by the cube root of 5 times 5 on the top to eliminate my cube root. So now I have 3 times the cube root of 5 times 5 upstairs, and I have the cube root of 5 times 5 times 5 downstairs. So, of course, 3 of them come out of the cube root, leave me with just 5. And upstairs, I have 3 times the cube root of 25 for number 28. 29 also asks me to rationalize the denominator. I have 2 over 5 minus root 3. So just like with the complex numbers, we need to multiply top and bottom by the conjugate, which will be 5 plus root 3. Multiply the top by 5 plus root 3. Multiply the bottom by 5 plus root 3. So on the top, I have what? I have 2 times 5 plus root 3, which of course is 10 plus 2 root 3. On the bottom, I have 5 minus root 3 times 5 plus root 3. Let's use the multiplication box to see how that behaves. 5 minus root 3 times 5 plus root 3. 5 times 5 is 25 plus 5 root 3. Minus 5 root 3, you'll notice those go away. Plus minus minus root 9, which is minus 3. Add all this together, those go. 25 minus 3 is just 22. So maybe I didn't want to multiply that out, because notice 2 divided by 22 gives me 1 over 11. 1 over 5 root 3 over 11. So a better answer than where I was going for when I distributed was to give me 5 plus root 3 over 11 for number 29. All right, next up we have 30, which will kind of require us to do something similar to completing the square. So on 30, I have x plus 3 squared minus 4 equals 16. Let's add 4 to both sides. Plus 4 plus 4. And I have x plus 3 squared is 20. Take the square root of both sides. Square root of x plus 3 squared is plus or minus the square root of 20. So I get x plus 3 is plus or minus. How do I do square root of 20? Square root of 20. Root 2 times 2 is 4 times 5. 2 comes out, it's 2 root 5. So x plus 3 is plus or minus 2 root 5. So x is negative 3 plus or minus 2 root 5. So x is negative 3 plus 2 root 5. X is negative 3 minus 2 root 5. So my answer in curly brace form, negative 3 plus 2 root 5. Negative 3 minus 2 root 5 is what I get for number 30. Moving on to 31, we have a polynomial long division question. So let's try that. We have x minus 2 for number 31, x minus 2 into 3x cubed minus 11x squared plus 12x minus 4. So we have to do our division. 3x cubed divided by x. 3x cubed divided by x is 3x squared. 3x squared times x is 3x cubed. 3x squared times negative 2 is negative 6x squared. Now I have to subtract this minus this. And the subtraction with the negatives is what causes problems. 3x cubed minus 3x cubed, that's gone. Negative 11x squared minus negative is plus. So negative 11x squared plus 6x squared would be negative 5x squared. 12x minus 0 plus 12x, negative 4 minus 0 minus 4. And let's divide again. This time negative 5x squared divided by x is negative 5x. So we get negative 5x up here. Negative 5x times x is negative 5x squared. Negative 5x times negative 2 is plus 10x. And again, we have to subtract. So we subtract, and what do we get? Negative 5 minus negative 5 is negative 5 plus 5 is 0. 12 minus 10 is 2. 2x. Negative 4 minus 0 minus 4. And then we divide one more time. 2x divided by x is plus 2. 2 times x is 2x. 2 times negative 2 is minus 4. And subtract. And we get a remainder of 0. So my quotient is 3x squared minus 5x plus 2. Now we're going to do the same problem again on number 32, except using synthetic division. So on number 32, it says 3x cubed minus 11x squared plus 12x minus 4 divided by x minus 2. So it's x minus 2, so 2 comes out front. Then we have 3, negative 11, 12, and negative 4. The 3 comes down. 2 times 3 is 6. Negative 3 plus 6 is negative 5. 2 times negative 5 is negative 10. 12 minus 10 is 2. 2 times 2 is 4. Negative 4 and 4 is 0. That's my remainder. So this is a number. This is an x. This is an x squared. So my answer is 3x squared minus 5x plus 2 using synthetic division, which is exactly the same thing I got previously by using polynomial long division. And we will go to our last problem, number 33. Which is the square root of 2y minus 1 minus the square root of y equals 1. I have two radicals. I'm only allowed to have one on a side. So I have to add the square root of y to both sides, which will give me Square root of 2y minus 1 equals 1 plus the square root of y. Then my next job is to square both sides, but be careful when you do that, you may be introducing bad roots. 2y minus 1 squared equals 1 plus root y squared. So the left-hand side is 2y minus 1. The right-hand side, 1 plus square root of y squared. Let's multiply that out. 1 plus root y times 1 plus root y. 1 plus root y times 1 plus root y. 1 times 1 is 1. 1 times root y is 1 root y. 1 times root y is 1 root y. Root y times root y is y. Add all those together, I get y plus 1 plus root y plus 2 root y equals y plus 1 plus 2 root y. And I miscopied the question. Let's fix it. Root 2y plus 1, 2y plus 1, 2y plus 1, 2y plus 1. Because if I hadn't fixed it, I recognize immediately I'd have no solution. So I apologize for miscopying it. Let's go ahead and subtract y from both sides. Let's subtract 1 from both sides. So now all I have on the left side is just y. All I have on the right side is 2 root y. So I'm going to square both sides again. Y squared, 2 root y squared. So I get y squared here. 2 squared is 4. Root y is y. I get y squared equals 4y. So y squared minus 4y is 0. Factor out the y. Y times y minus 4 is 0. So y is 0 or y minus 4 is 0. So y is 0 or y is 4. But we have to check that. Y is 0 or y is 4. So we've got to go all the way back to our very first problem, which was this once I copied it correctly. 2y plus 1 minus root y equals 1. Let's check 0. Let's see if 0 works. Plugging in 0, root 2 times 0 plus 1 minus root 0. Does that equal 1? 2 times 0 is 0. 0 plus 1 is 1. Root 1 minus root 0 is 1. That's a yes. So 0 is okay. Now let's try 4. Again, in our very original question, root 2y plus 1 minus root y, does it equal 1? Root 2 times, this time we're using y of 4. 2 times 4 plus 1 minus root 4. Does that equal 1? Does that equal 1? 2 times 4 is 8. 8 plus 1 is 9. Root 9 minus root 4. Does that equal 1? Does 3 minus 2 equal 1? The answer to that again is yes. So both of those answers are good. Both 0 and 4 are correct. I like to write my final answer in curly brace form. Curly brace form 04 is our solution to that problem. And that will conclude this final video on the final exam review for intermediate algebra.